Ladies and gentlemen, now, we will start the fourth lecture of the Improve phase. During the lecture, the following topic will be covered: setup reduction. Setup reduction is the process of reducing changeover time. Since setup activities add no form, fit, or function to the product, they are by definition non-value adding. Benefits from setup reduction: reduce lead time, resulting in improved delivery. Improved documentation of setup processes, leading to improved processes. Decreased inventory and costs, while increasing capacity. The tool for tackling setup time is the 4-step rapid setup method. The principle of this method is to eliminate anything that interrupts or hinders productivity. SMED, or single-minute exchange of dies, is name of the approach used for reducing the output and quality losses due to changeovers and setups. Single minute means that necessary setup time is counted on a single digit. This method has been developed in Japan by Shigeo Shingo and has proven its effectiveness in many manufacturing operations by reducing the changeover times of packaging machines from hours to minutes. Changeover loss is one of the 6 big losses that have been defined within the Total Productive Maintenance (TPM). It is important to note that SMED is directly linked with the analytical process of OEE, overall equipment effectiveness. Step 1. Document the setup procedures and label each as internal or external. Internal setup: an activity that must be performed by the operator of the process, even if it interrupts value-add work. Manufacturing example: exchanging dies or fixtures in the machine. External setup: an activity that could be performed while the equipment is producing parts, where the process operator is conducting other value-add work. Manufacturing example: retrieving tools and hardware. Tool 1. Setup Documentation Worksheet. The worksheet includes the following for each setup event or task: the sequence of the event, the start time, event description, the elapsed time, and specify if it is internal or external. Tool 2. Area Layout helps you understand what movement and motions are required by setup personnel. Use the diagram to track pathways of operators, setup personnel, to determine the total distance traveled during the operation. Tool 3. The Before Timeline. Used to graphically show each event within the setup and highlight which take longest. Leave room for the after. Tool 4. Improvements Worksheet. Brainstorm and list improvement opportunities. Estimate the net reduction in setup time from the improvement. Step 2. Offload internal setup to external setup wherever possible. Focus on any activity or task that causes you to stop the process. Then ask why you have to stop and figure out how to eliminate that source of delays or interruptions. Brainstorm ways to convert internal setup to external setup. What could you do make the information, equipment, materials, etc., available to the process operator without requiring him or her to interrupt value-add work? For example, have computer programs compile orders every evening, so all the information is waiting for order processors the next morning. Step 3. Streamline internal setup. Look for ways to make any setup that must be done by the process operator more efficient. For example, redesign the workplace to simplify, reduce, or eliminate movement, Put manuals or tools within arm's reach. For example, link databases, so complete customer information is automatically filled in when an operator enters a name or address. Step 4. Eliminate adjustments required as part of setup routines. Adjustments and test runs are used in manufacturing to fix inaccurate centering, settings, or dimensioning. Use mistake proofing, visual controls, process document, and any other means you can think to make sure that equipment settings, part placements, etc., can be performed perfectly every time. Abandon reliance on intuition. Do studies to get data on what settings are best under what conditions, what procedures result in most accurate part placement, etc. The document results from the 4-step rapid setup. The document highlights the conversion from internal setup to external setup. Before and after chart shows the setup times before and after conversion and reduction. Examples of practical tools: suppress non-value-added operations and convert internal setup operating into external setup. The data from OEE and the preparations of prerequisites, for example tools, changeover parts, pre-assemblies, preheating, mobile storage, etc., are reviewed to achieve results. Some internal setups have been converted to external setups. Simplify the design of the machine, especially fillings and tightening mechanisms. Some examples of the design simplification are U-shaped washers, quarter-turn screws, and cam and lever tights. Balance the work content of the line and ensure teamwork. For example, in one automatic insertion machine, one operator sets up on the machine front, while other operator feeds components on the other side. Minimize trials and controls. Use of mistake proofing or poka-yoke enables the standard solution to be carried out each time. For the following tasks, define the internal setup activities and external setup activities: placing the new tool, fetching new tooling, clearing hoppers or material feeders, finding tools for the setup, removal of the old tool, finding correct paperwork, returning the old tooling, connecting services such as air to new tool, fetching raw materials, removal of guarding from equipment. Please pause the lecture and solve the exercise. External setup activities are fetching new tooling, returning the old tooling, finding tools for the setup, finding correct paperwork, fetching raw materials. Internal setup activities are removal of guarding from equipment, removal of the old tool, placing the new tool, connecting services such as air to new tool, clearing hoppers, material feeders. A case study took place in a mold-making firm. By analyzing the setup operations on the shop floor, recording the whole setup process, and describing the setup operations, tracking setup times, and measuring die-cast movements. The initial analysis was very important for obtaining a correct diagnosis to underpin the improvement of the negative aspects of the production system. Part of the analysis included several interviews with the workers involved in setup operations. These interviews targeted the knowledge of the whole setup process, namely the sequence of the operations, the major difficulties faced, the type of training, the development of skills, the quality assessment, etc. Another part of the analysis included observation of the setups and calculate the average time of each activity, which have been recorded in the table next. As a Six Sigma expert, Please perform the following tasks. Separate internal from external operations. Convert internal to external operations. Streamline all aspects of the setup operation in order to accomplish the different tasks in an easier, faster and safer way. The analysis included observation of the setups and calculate the average time of each activity. Please pause the lecture and solve the exercise. First, we draw the activity's timeline as before state. The timeline includes all the operations. Separating internal from external setup operations involves distinguishing all the activities of the setup operation and to divide the setup in stages. Thus, the setup was divided into the following 4 stages. 1. Operations to be accomplished 1 hour before the machine stops. 2. Operations to be carried out immediately before the machine stops or in parallel with other operations during setup. 3. Operations to be carried out during the setup operation. 4. Operations to be accomplished after the machine is back to normal production. Now, we can see the internal activities and external activities. There are the operations to be carried out during the setup operation. There are the operations to be carried out immediately before the machine stops or with other operations during setup. There are the operations to be accomplished after the machine is back to normal production. At the end, we draw the activity's timeline as after state, and we can compare with before state. Please perform the activity and send your outputs by email for assessment. Thank you, and see you in the next lecture of Improve phase.